Okay, so today we're going to continue with our equation of straight lines, but we're going to look at the different ways that we can write the equation of a straight line. Just like you can have equivalent fractions that mean the same thing but are written differently, you can do exactly the same with straight lines. And up until now, at GCSE, we have just come across the equation of a straight line in the form y equals mx plus c. And this is called the gradient y-intercept form, because your m is the gradient and the c is the y-intercept. But there are two other forms that we need to look at. And the first one is called the gradient point form. And this looks like this: y minus y1 equals m x minus x1, where m is the gradient. So just like the y equals mx plus c, m is the gradient. But the point x1, y1 is a point on the line. Okay, so that's the second way that we can write the equation of a straight line. And then the final way is what we call the standard form. And this looks like this: ax plus by plus c equals 0, where a, b, and c are integers. It can be positive or negative, but they have to be whole numbers. Okay, if you ever watch any YouTube videos and see an American version, they quite often write it like that: ax plus by equals c. And again, if you're watching American videos, they call gradient slope, okay, whereas we use the word gradient. So we're going to go back to this one first, the gradient point form, and we're actually going to prove this equation here, okay? So to do that, I'm actually going to go through a question first, and I'm going to say, what is the equation of a line who's got a gradient of 2 and it goes through the point 3,5? So it's always a good idea, well, it's not a good idea, it's essential, you should always sketch 3, 5, so we know it goes through the point 3,5. It's got a gradient of 2, so it's going to look like that. Now, I could use y equals mx plus c, but I'm trying to prove something here. And I'm going to say, I'll tell you what, I'm going to put a second point on this line, and I don't know what it is, so I'm going to call it a general point xy. And so I've got x on the x-axis, y on the y-axis. I know my gradient is changing y over changing x. So putting my triangle on, which is what we always do, what is this distance here for the change in x? Well, it's going to be x take away 3. What's the change in y going to be? Well, if we look over here, then we can say that's going to be y take away 5. So I know my gradient is going to be change in y take away 5, over change in x take away 3. But I know my gradient is 2 because I'm told it up here. So I can actually write 2 equals y take away 5 over x take away 3. And so what we tend to do is we don't like the fractions particularly at this point, so we multiply by the x take away 3, and we end up with 2 times x take away 3 is equal to y take away 5. And written the other way round, because that's how we tend to write it, that is the equation of the line in the gradient point form. But how do we actually get that equation? Okay, because it is quite nice to remember the equation and just use it. So I'm going to say my line has got a gradient of m, and it goes through the point x1, y1. So sketch it. Got my point x1, y1 right there. Got a gradient of m. Don't know what that gradient looks like, but I'm just going to draw a line. So again, I'm going to put a general point on this line at x, y. So that's at the point x, y. Gradient of the line is change in y over change in x. So put my triangle in. How am I going to do the change in y. What's that distance that the line goes up? Well, that's going to be y minus y1. What's my change in x going to be? The distance that it goes across is going to be x minus x1. So my gradient is y minus y1 equals x minus x1. But as I was told before, my gradient is m. So I can write, m equals y minus y1 over x minus x1. And again, just like we did when we did the exact example, if I multiplied by this denominator to try and remove the denominator, I get m brackets x minus x1 is equal to y minus y1, and we just tend to write it the other way round. So that is the equation of a line in the gradient point form, and you can just remember this equation and quote it. Okay, so I would like you, we're going to do this example together. So we're going to write the equation of a line that goes through the points 2, 7 and minus 1, 3 in the gradient point form. So as always, we sketch. We got the point 2, 7, which goes right there, and we've got the point minus 1, 3, which goes through there, and there's our line. So as in most cases, the first thing we have to do is work out the gradient. So we put our little triangle in, and our change in y, well, we've gone from 3 to 7 on the y-axis, so we've change in y is 4. And our change in x, we've gone from minus 1 to 2 on the x-axis, so that's got a change in x of 3. So my gradient is 4/3. Okay, so now I've got two ways of writing this because I can choose which point I want to use. So let's use the 2, 7. So I've got y minus y1. So the y value of the coordinate is 7 is equal to the gradient times x minus x1, which is the x part of the point, which is 2. So there we go, we've got the equation in the gradient point form. But I could use the other point if I wanted to, and in that case I could say y minus, well, the y value of the other point is 3 is equal to 4/3 x minus the x value is minus 1. So the only difference is we would tend to write that as y minus 3 is 4/3 x plus 1, because when you take away a negative number, it is the same as adding. So here we go, another one, the equation of a line through the points that, and that in the gradient form. So I'm going from minus 5, 7 to minus 2, 2. So, as always, draw the sketch. Minus 5, 7, it's going to be somewhere up there. Minus 2 is going to be somewhere down there. So you've got your straight line. Your gradient is change in y over change in x. So as always, we've got to draw that triangle in, going from one point to the other. What was the change in y? Well, it went from 7 to minus 2, so it went down 9. So it's a change in y of minus 9. Over the change in x, it went from minus 5 to 2, so it went across 3. So the gradient is minus 3. So again, we can now write this in two ways because we can use either point. So I can say y minus 7, because 7 is the y value, is equal to minus 3 times x minus 5, because that's the x part. So tidy that up, would be minus 3x plus 5. Or I could use the other point, and in that case, I'd write y minus 2, because the y part is minus 2, is equal to minus 3 x minus 2. Because again, the x part of the coordinate is minus 2. tidy it up. Y plus 2 equals minus 3x plus 2. Right. Have a go at these yourself. So again, I want you to write these in the gradient point form. Draw the sketch, work out the gradient. You can use either point if you want. In a second, I'll show you the solutions for both cases. So press pause and have a go. Okay, so here we go. It's the solutions. I'm just going to show you nice and quick. For number 1, the gradient is minus 2, so the 2 equations are there. Number 2, you end up with a gradient of a half. So again, using either point, you can write this. Notice when you do y take away 0, you don't then have to write the y take away 0. So although this doesn't look like y equals a half bracket x minus 1 that is in the point gradient form, it is. So you've not got to worry about that. And the same for number 3. Okay, so again, using either point, you ended up with a gradient of 7/5. And the final one, that's the solutions you should have had. Okay, so we've done the gradient point form and we've done the gradient y-intercept form. And now we're going to look at the standard form. And you can never really get the standard form directly. You can only ever get the standard form by having the y equals mx plus c, or by having y minus y1 equals mx minus x1, and then converting it into the standard form. So it's simply a case of rearranging an equation. So in the case of y equals mx plus c, you've just got to get everything to one side of the equation. So I'm going to take away the y, and I'm going to get 0 equals, and because we tend to write it as x, y, and then the constant, is going to be 3x minus y plus 4. Nice and simple. If you're doing the other side, you've got to expand the bracket first. It's usually the best thing to do. So you end up with y minus 2 equals 3x plus 3, because you've got to remember both parts. And then again, you've got to get all the parts, all the terms onto one side of the equation. So personally, I'd probably add the 2, so I'd have y equals 3x plus 5, and then take away the y, and 0 equals 3x minus y plus 5. Okay. Now, when fractions are involved, obviously it can get a little bit more tricky, but general rule is you've got to get rid of the fraction. So in this case, I would multiply through by 4, because that will get rid of the denominators. Remember, when you're multiplying through by a number, you've got to multiply every term by that number. So we end up with 4y equals minus a half times 4 is going to be minus 2. So you end up with minus 2x plus 5. Now, before I've always moved the y, and you can move the y, and it doesn't matter. So I'd take away the 4y, and I'd end up with 0 equals minus 2x minus 4y plus 5, and that's fine. But I just tend to like having my x's as positive, just because I don't like writing that minus at the front. So I probably would actually take the 2x to the other side by adding the 2x, and end up with 2x plus 4y equals 5, and then taking away the 5. So you have 2x plus 4y minus 5 equals 0. Both are correct. It doesn't matter which one you do. It's just a personal preference. Right, now then, with this one, nice and complicated. So let's have a little look. You could expand the bracket first. And with a lot of maths, it doesn't matter which way you do things. Some people choose one way, some people choose another. It doesn't matter. So you could decide to expand the bracket. So you've got to do this times this. So I need negative times negative is going to make a positive. And then 2/5 times 3 would be 6/5. Okay. Then we want to try and get rid of this fraction. So multiply through by 5. So multiply every term by 5. So we end up with 5y plus 15 is equal to minus 2x plus 6. And now we've just got to get everything on one side. So again, I would add the 2x. So I have 2x plus 5y plus 15 equals 6. And then take away the 6. So I'd have 2x plus 5y plus 9 equals 0. So you can have a go at these. Again, press pause and I will quickly show you the solutions. Okay, number 1, multiply by 3 first. Remember to multiply every term. The mistake people will make will be in forgetting to multiply that, so be careful and rearrange the equation. Number 2, expand out the bracket, rearrange the equation. Number 3, try and get rid of that denominator, multiply by 4 everywhere. And number 4, biggest case here where people make a mistake is doing this, okay? Negative times a negative makes a positive. And I've made a mistake in my solution because that should be a 6 because a 3 times 2 is 6. So that should be a 6. So I should take away a 6. So actually, that just becomes 3x plus y equals 0. Okay, number 5, again, multiply through by the 5 to get rid of that 5 in the denominator of the 3/5 x and rearrange. And actually, I decided to do number 6 a little bit differently. I decided to multiply by 3 first. Okay, and because this is 2/3 times all of x plus 1, the 3 is cancelled there. So then you have 3y plus 6 equals 2 bracket x plus 1 and then expand. It wouldn't matter if you decided to expand first, you should get the same answer. And the final 2 rather, multiply through by 9 and rearrange. And again, I decided to multiply by 5 first and then expand the bracket. And again, biggest mistake would be here. Minus 1 times minus 4 is plus 4. Okay. This is the first part of today's lesson. There will be a second part and a worksheet for you to do. You could, if you want, go and do the worksheet, the questions on this, then watch the second video, or you can watch the second video and do the whole worksheet. It's up to you. But let me know on Edmodo how you've done.